Hi, my name is Chris VanDixon, and today I'll be doing a presentation on the environmental impacts of petroleum-powered vehicles. A little background on this topic. There are an estimated 1.1 billion cars on the road worldwide today. Of these 1.1 billion cars, approximately 1.4% are natural gas-powered vehicles, while a mere 0.1% is an electric vehicle on the road today. This leaves approximately 98.5% of all cars on the road today being petroleum powered. Doing some simple math, we can see that multiplying this 1.1 billion cars times the 0.985, we get 1.083 billion vehicles on the road today being run by petroleum products. These petroleum products would include both gasoline and diesel of all types. There are, of course, a high amount of environmental concerns with petroleum, one of which being that when petroleum is combusted, it produces greenhouse gases. The transportation sector emits the second highest amount of greenhouse gases among any sector in the United States. About 27% of all greenhouse gas emissions come from the transportation sector. The only one that's higher than this is the electricity sector, which accounts for about 31% of our greenhouse gas emissions as the entire globe. As you can see in the chart below, greenhouse gas emissions peaked around 2007, but this is not necessarily meaning that greenhouse gases are going away. Every year, more and more cars are going onto the road, and thus more greenhouse gases are being emitted each year. More specifically, one of these greenhouse gases that we've all heard of is, of course, carbon dioxide. Carbon dioxide accounts for approximately 95% of all vehicle emissions. The average vehicle on the road today emits about 5.5 metric tons of CO2 each year. Doing some simple math, we can see that this 5.5 metric tons times the amount that I mentioned earlier, 1.083 billion vehicles on the road, accounts for almost 6 billion metric tons of CO2 released into the atmosphere each year. One of the surprising things about CO2 is that it is not actually classified as a pollutant. This being because CO2 is a naturally occurring element in the atmosphere, as well as it is needed by plants for photosynthesis. One of the bad things about CO2 being in the atmosphere is that it cannot be absorbed quick enough by these plants. This excess CO2 then traps heat in the atmosphere, thus warming the Earth. Also, one of the effects it has is narrowing the sky window. For those of you who don't know what the sky window is, it is what allows certain wavelengths of light to be emitted back into space, thus cooling the Earth, part of the greenhouse gas effect, which is necessary, of course, to keeping our Earth's temperature regulated. Looking at two more of these greenhouse gases, we have methane. Although it is much less emitted as far as percentage overall, it is much more volatile than CO2. It is better at trapping heat by about 20 times more than CO2, and unlike CO2 remaining in the atmosphere for roughly 1 year, methane will remain in the atmosphere for up to 15 years. Looking at also nitrous oxide, which is the most volatile of the three, that is better at trapping heat than CO2 310-fold and can also remain in the atmosphere up to 120 years. So what are some possible solutions for this issue? The first being public transportation, of course. Full buses can remove up to 40 cars from the road, while full passenger trains can remove upwards of 500 cars for the same amount of passengers on the train. Public transportation on average cuts petroleum combustion by more than 50% in total fuel used. You can also increase the fuel efficiency of your cars. Vehicles that achieve 15 miles per hour emit about 12 metric tons of CO2 per year, while vehicles that achieve 50 miles per gallon emit almost 1/3 of that, being 3.5 metric tons of CO2 per year. So in conclusion, the environmental impacts of petroleum-powered vehicles are that its combustion produces a massive amount of greenhouse gases, which in excess can be harmful to the planet. GHGs trapped in the atmosphere will heat our planet to unsustainable levels, and also, as I said before, narrow the sky window. It is our job as engineers to mitigate these impacts to the greatest of our abilities.